Hi, welcome to Think Human. I'm Chris, and in this video I want to talk about the way that we look for life in our universe. How do we find other life forms? So far we haven't done a great job. We have been trying, but not as hard as we could have arguably, but we have done some efforts and a lot of thinking about this. So the way that we basically look for life now is we look for planets that are kind of like our planet. We look for planets that are in the so-called Goldilocks zone. And the Goldilocks zone is a property of the planet not being too far away that the water on its surface would freeze, or not being so close that the water would boil and evaporate away. So it's the Goldilocks zone. It's just right that water would be liquid on its surface. And given that we look at planet Earth and life on planet Earth, we think that liquid water is necessary, and thus everywhere else in the universe we also look for liquid water. I would say that this is a limiting factor for us to be so human-centric and Earth-centric, to think that everything must be just like it is in here. It is very possible that life is way more common than we think, and reasons that we haven't found signs of life yet might be various, but not because there isn't some. Even on our own planet, there are extreme organisms that can deal with extremes of heat, extremes of cold. We have organisms that don't need oxygen. We have organisms that can live entire ecosystems, that can live without any sunlight at all the energy coming from the core of the planet, from the molten core, and the heat coming upwards. Even on our own tiny planet, and not to mention, we have these small little interesting creatures who are highly resistant to radiation that's nowhere on Earth, and highly resistant to living in the vacuum of outer space. What were they, tardigrades? These little small water bears, I think they were called, these microscopic small organisms, but incredibly resistant to all types of environmental effects, and they can even survive in the vacuum of space. So an interesting question, why are they like that? Did they come here by some kind of asteroid? Life can travel between planets by collisions to planets, and then rocks are flown into space and bacteria on them collide with another planet, and then bacteria start growing there. That's an interesting story to talk about. But even in our own planet, we have so many examples of life being really in extreme conditions for no obvious reason to be. And we know in our own solar system we have the moon Europa and the moon Enceladus around Jupiter that are ice moons, and they're covered with kilometers and kilometers of ice. But below that ice there are liquid water oceans that have more water than entire planet Earth has water, and they have been here for billions of years. So think about the possibilities of all that time of something actually happening there and life arising, which is incredible to think about. So I think we're limiting ourselves by only looking at things in the Goldilocks zone, so to speak. But this is only due to the fact that we are just beginning. We can't make more specific observations. We can now tell, how far they are, how big they are, the planets around other stars. We can't tell anything more, except now we're beginning to find refined methods of when a planet actually passes around the star in our field of view when we're watching it. Then we can see the light change a little bit. And depending on the light change, how the spectrum of the light changes, we can find patterns in it. So if the light passes through an atmosphere of helium, we see certain sort of pattern. If the light passes an atmosphere of oxygen, we see another pattern, and so on and so forth. So we can begin to see already the composition of alien planet atmospheres and what they might be like. But again, I think we shouldn't be looking for oxygen necessarily, or CO2 or methane or anything like that. They might be solid signs of life, but again, this is just a start. It's really reasonable and obvious that we start off by looking for other planets that have similar conditions to us, because at least we know 100% that it's at least possible for life to arise in the Goldilocks zone and having a certain kind of atmosphere like we do. But it's limiting, and astrobiologists who are studying all this stuff, they are moving into other realms as well, and looking at pictures on a sort of more expanded view of what might be possible, because we know that so many things we thought were impossible become to be possible. Life has such tenacity. life has such will to live and plasticity to move, change and evolve. I had this thought a while ago that life wouldn't necessarily need planets. I imagined a cloud of interstellar gas which had a lot of organic molecules and stuff going on. Some life forms could evolve there in just a vacuum of space, growing organisms, and you can imagine as time goes on, if they get offspring and entire ecosystems without any planets or atmospheres needed in the equation. So this is quite a far out and extreme thought of thinking about it, but in the vastness of the true expanse of the cosmos we live in, I wouldn't say it's such a far off thought to think of such possibilities. If it is physically possible, it will happen and has happened somewhere. So I would be really interested to one day find, if you're traveling among the stars, of some life forms that have evolved in the interstellar medium of space in gas clouds by eating some other organisms or gas, and then having some propulsion mechanisms like some organical biological spaceships. It's a crazy idea, but it would be incredibly interesting to think about that. So I think my point is that we are limited in the sense of what we think is possible, and also another thing, we are made out of carbon, because carbon is an element that makes really good connections. It's an organic molecule. A lot of chemistry can happen with carbon, but I think it's a fallacy to think that carbon would be the only thing that could have life arise from it. There are many elements that have been proposed that might potentially also give rise to life. So one of those would be silicon, for example, and I'm sure there are many more. We are just started our scientific journey of learning about the universe and the world around us, and there's so many things we do not yet know. I would not be surprised if the life we find is something absolutely unlike anything that we find on Earth. And that would be incredibly enlightening and interesting. And until then, until we actually get to other stars, we still have our own solar system and the moons of Jupiter, Europa and Enceladus. And if we find life there, that would be incredibly interesting. And even on Mars in the past, if there would have been. So these are just my short thoughts on this, how I think we are a bit constricted by looking at everything through the lens of what is possible on Earth, when the true possibilities in the cosmos might be much more vast. But thankfully people are really getting to be more aware of this and keeping it in mind and expanding what they think is possible and what life is possible. And I'm sure even on our own planet we will continue to find organisms in places where before we thought is impossible. We saw them in the ice of Antarctic, we see them in the deepest depths of the ocean, underground, in the atmosphere, floating. It's absolutely insane. So these are just my thoughts. Hope you liked the video. If you have any thoughts, please share them in the comments, and of course, thank you so much for watching and take care.